702 and Cape Talk.
The Naked Scientist.
Hello, Chris. All the best for this year.
Yeah, morning, Eusebius, and Happy New Year to you. It's the first time for you and me in January 2019, isn't it?
Yeah, looking forward to it. Love having you on this show. We already have plenty of people who've called in, by the way. Let's get straight into it. Paul, good morning to you. What question have you got for Chris?
Good morning, Mr. Bishop. Chris Daniel speaking to you. Can a person shop in the shower? I know my mom has always said so, but I've never heard of somebody shopping in the shower. That's my first one. My second one, when I feed my dog food, his poo is the normal color. But if I change to table scraps like, pap, rice, whatever, macaroni, whatever's left over, it quickly turns to white, unlike human beings where it doesn't change so soon except if you're eating beetroot. That's B. And my last quickie is...
Okay, hold on. Too many questions. One bite of the cherry. I didn't even hear Paul's first question. It was so quick. I don't know which one you're going to pick. The one that I heard was about dog poo color being more susceptible to change than human poo in response to diet. Is that true?
I don't think anyone's done the study. It's certainly true that dog poo does go white if you leave it on the pavement, but it goes white less often if there's less bone material in the dog food. And we used to see a lot more white a lot more white dog poo in the past. And I think that's because the representation of bone meal and other materials like that in the dog food was possibly a bit higher. That whiteness is calcium and phosphate, calcium phosphate from bone in the dog poo. I don't know whether human poo does the same thing, but certainly if you go into the outback or the bush and you have a look at what wild animals leave behind, you will see lots of evidence of white poos because of the phosphorescent bone, especially in hyena poo. I certainly have seen leopard poo as well. That goes very white. When they crunch up all the bones to get the marrow out of the middle of the bone, they end up swallowing lots of bone fragments that goes with it. This comes out the back end and you get poo that does, when it dries out in the hot sun, very quickly goes a white colour. So I suspect that the whiteness being seen is probably because there's a higher representation of calcium-type materials, probably bone, but maybe some other things in there, and that's what's doing it.
Oh, that's fascinating. Gift, good morning to you. Welcome to the show.
Morning, how are you?
I'm good, thank you. Gift, what question have you got for us?
My question is, what happens to the brain when one is sleeping? In connection to the dreaming and stuff, does the brain also sleep, or it continues to dream? What is the relationship between sleep, brain, and whatnot?
Okay, thanks, Gift.
Eusebius, can you just summarise the question for me, because the line wasn't too great?
He wants to know, Chris, what happens to the brain when we're asleep? Obviously, we dream, he adds quickly, but he wants to know in general, does the brain also sleep?
Yeah, I mean, we spend a third of our lives asleep, and if you look at almost any other animal we've studied, they also devote considerable amounts of their life to sleeping. So this tells us that it must be some very important thing that the brain does. There must be an important role for sleeping. Some animals have very specialist types of sleep. If you're a dolphin, for example, you sleep one half of your brain at once and leave the other half relatively active. Obviously, if you're swimming around in the ocean and you need to remember to breathe and not put your head underwater, if you're asleep at the time, that can be tricky, which is why these marine mammals have specialised to do that. But humans largely sleep their entire brain at once, although there is evidence that if you sleep in a new environment, that one half of your brain tends to be a bit more active on the first night that you're asleep away from home than on subsequent nights, probably to increase your vigilance so that you can detect danger. But when we go to sleep, what your brain does is, the first thing it does is disengage from your body. It turns off all of the signals that would normally go to make you move so that you don't end up acting out your dreams. So you go into a paralyzed state. So only very specific movements like rolling over or breathing continue. You can also cough as well, because that's important to keep your airway clear. You also go through, as you go to sleep, different phases of sleep. And there are different stages, and they range from drowsiness and dropping off right down into very deep sleep. And then periodically through the night, you go into a phase of what we call REM sleep. REM stands for rapid eye movement sleep. When people go into this phase, that's when they're dreaming. And when we look at people who are in REM sleep, their brain has become incredibly active. Lots of the different brain areas are independently displaying surges of brain activity. And then they drop back into a deep phase of sleep. And this is repeated many times through the night. But on each occasion, with repetition, the phase of the REM sleep gets longer. And we know if you wake people up when they're in that REM sleep phase, that's when they will report they were just having a dream. And as you go through the night, as those REM phases lengthen, when people are woken up and asked, do you have any dreams to report? They'll say that their dreams get richer and more detailed the further into the night, i.e. the longer those REM sleep phases become. We don't know why we do this. We don't know the role of sleep. We just know that it's fundamental to good health, because if you deprive a human or an animal of sleep, it becomes very unhealthy. We also know that sleep is very important for the consolidation of information. People who learn things, sleep, and then are asked to recall the information do much better than people who are just either asked to learn something and then immediately recall it, or are asked to learn something and are then deprived of meaningful sleep for a period of time. We think that one of the other things that happens when you sleep is that the brain flushes out all of the rubbish that accumulates. I don't mean cognitive rubbish, I mean chemical rubbish and waste that accumulates during the day. The dustbin collectors call at night when you're sleeping in your brain. This is probably because the brain is a very specialist chemical environment, and it cocoons itself away from the rest of the body behind something called the blood-brain barrier. And this is to protect the delicate chemistry of the brain, because during the day, your blood chemistry can change quite radically. You can also change the various constituents and chemicals because of what you eat and so on. So the brain keeps itself separate so that it preserves its delicate neurochemistry. At night, a system called the glymphatic system kicks in, and various channels open up and flush out the brain. All the rubbish is washed away into the bloodstream, and this is when the brain resets itself. And so probably there's a range of different reasons why we sleep. One of them is washing out the debris that accumulates during the day. The other is consolidation of knowledge. And the other is probably the mundane thing that if you're asleep, you're not in danger so much. You'll go and find somewhere away from everybody else and go to sleep there. So if you make your sleep coincide with nighttime, which humans do, and nighttime's when you're more likely to get eaten by a wild animal, you can see how, from an evolutionary point of view, retreating in the dark to go to sleep and spend the most dangerous part of the day asleep, you could see why that would be evolutionarily advantageous.
That's fascinating, Chris. I wonder if I can ask you a follow-up question from the peanut gallery here, i.e. me. The nighttime sleeping advantages that you mentioned, we had a really fascinating historian on the show last year who spoke about the history of sleep. And one of the points that he had made that he'd come across as part of his research into the history of sleep is that throughout history, there were periods where, especially before industrialization and mass commerce, human beings would sleep 2 or 3 times in a 24-hour cycle rather than having one sleeping period at night for 8-10 hours, but that it serves capitalism and commerce for us to be socialized into thinking that the best and the only time to sleep is to have one sleeping period in a 24-hour cycle after night. Does science help at all? Is there scientifically an advantage to sleeping when it is nightfall, or can one get all the sleep you need in 2 or 3 short bursts throughout a 24-hour cycle?
The evidence is that you do need a certain amount of sleep in any 24-hour period, and that amount will vary from one individual to the next, but at least 7 hours seems to be the most consistent with good health. If you sleep for fewer than 7 hours a night, you tend to have people having worse health outcomes. If you sleep for more than 7 hours, and certainly more than 8 hours, some people will have ill health effects. So there does seem to be an optimum. There's no easy answer to your question. It seems to be that people should sleep when they feel tired, but the usual answer to this is if you find yourself dropping off during the day, you feel intense sleep pressure and you feel very tired and you need to go and have a nap, then that may be telling you something about your lifestyle in general, and it may be telling you that you're not getting enough sleep when you are trying to sleep. So if you are accustomed to sleeping a bit less at night but then making up for it during the day, and that's your habit, that's absolutely fine. But if you find yourself feeling so excruciatingly tired during the day that you have to go and have a nap, that probably tells us that you're robbing away from your nighttime sufficient sleep, and you should probably augment the amount of sleep you're taking at night. The thing that's the big driver, and you mentioned industrialization, Eusebius, with industrialization has come energy supply and artificial light. And as my good friend Russell Foster, who's a pioneer of the body clock and an understanding how the body goes through its circadian rhythm, often says, what artificial light has enabled us to do is to invade the night, where previously we would have had a very strong go-to-bed signal coming to us. No light, quiet, go to sleep, we would have all gone to bed much earlier. Because of artificial light, people are staying up much later, so they're robbing themselves of that natural sleep time. And so some people's natural response to that is to sleep a bit more, make up for it during the day, but it's not necessarily as healthy.
Fascinating. Let's go to the voice notes. We've got a question there as well.
Hi, Yubi. Hi, Chris. Do we have the full spectrum of minerals required for batteries that power electric vehicles? If so, why aren't we manufacturing the actual batteries instead of just exporting the minerals?
Not sure I understand that, but you're the scientist.
Well, I mean, the point that's being made here is about electric cars, and this is a very important time in the history of automation and automobiles, because we're going to see a very big shift in the coming years away from the use of fossil fuels towards electricity and electric vehicles. What has been holding back, as our caller alludes to, the field of electric vehicles, though, is the power supply. Because if you remember the mobile phones of about 30 years ago, they were about the weight and about the dimensions of a house brick. They were absolutely huge. That wasn't because the electronics in them were absolutely huge. It was largely all the batteries. Now batteries have improved enormously, but they're not good enough yet. Electric cars, the battery demands are really considerable, and the industry hasn't quite got the perfect batteries yet, but they are working on it. And there are a lot of very important developments in the works at the moment that I think within the next 5 years or so we're going to see significant improvements. And I think that certainly my next car that I buy, I have a diesel car at the moment because I use that for long distance driving, but for round town it's absolutely appalling. For short journeys on a cold day, the engine never reaches operating temperature, the oil never reaches proper lubricating temperature, so you're knackering your car. You're also producing enormous amounts of emissions, which are really bad for the environment. I've said when I've driven that car into the ground, and I don't know how many tens of thousands of kilometres it has left on the clock, my next car is going to be an electric one. So I think once we have that technology and we have those batteries, then the whole world will embrace that technology, because for very big cities, especially cities like Johannesburg, where you have lots of slow-moving traffic, then electric cars will be a game changer, because the air quality would transform overnight if we got lots of electric cars on the vehicles. The downside, at the moment, they're very expensive. So it's not going to happen immediately, but it's going to happen because the benefits are going to be so huge in terms of energy efficiency, but also quality of environment.
Got a really interesting question on our SMS line. Let's take this one. It's also about dogs, but slightly different. Tessa says that her son and daughter-in-law immigrated to Australia, Chris, and they took the dogs with. They flew via Dubai and Dubai to Melbourne. And her question is straightforward. Do animals also suffer from jet lag?
Yes, they absolutely do. Welcome to Australia as well to those people. They absolutely do. They have the same structures in their brains that keep time as we do. The area of the brain that is your master body clock is called the suprachiasmatic nucleus. This is located in the heart of your brain in a region called the hypothalamus. It's about the size of a grain of rice. There's about 20 or 30,000 nerve cells in there. And those nerve cells are keeping time using a genetic clock. So you have a sequence of genes where the first gene turns on, and this switches on a second gene, which then turns on a third gene, and meanwhile feeds back and turns off the first gene. And this cycle takes about 24 hours to tick round. And as it does so, it changes the activity of that cluster of nerve cells, and that cluster of nerve cells relay their activity to other parts of the nervous system. They also lead to the release of various hormones, including a very important one called cortisol, which goes round in the bloodstream and visits every cell in the body, informing every cell in the body what the time of day is. Now, we worked out a lot of that on the basis of work done in animals, because mice have the same structures right through to dogs, kangaroos. The only exception to this are animals that live in areas of the world where there is no day-night cycle, that is a 24-hour cycle. You can probably think immediately of two of those places, the North Pole and the South Pole. And there are animals that live there where for 6 months of the year it doesn't really get light, for 6 months of the year it doesn't really get dark. So for them to try to use a day-night cycle to set their clock doesn't really work. And scientists have studied these animals, and they do have body clocks, but they just ignore them. So it's almost like they have a clock, but they've just taken the hands off the clock, and they don't bother to look at what the time is, but they have another kind of clock running that tells them what time of year it is, because they need to know the time of year so they can mate. And there's a third group of interesting animals that also have body clocks, and they know what time of day it is, but they can also tell when the next high tide will be. These are animals that live at the seaside. They feed when the water comes in, they hide when the water goes out. They therefore have a clock that runs to a 12-hour cycle, and it advances by an hour every day, so they know exactly when the next high tide's going to be.
Tino, thank you so much for holding on. What is your question?
Good morning, Eusebius and Dr. Chris. I would like to ask the naked scientist, is time travel possible?
Well, you could argue, Tino, that everyone's a time traveller. Everyone listening to this programme is time travelling right now. We're going forwards. We unfortunately haven't found out where the reverse is. There's a number of perspectives on this. Stephen Hawking famously said, "I don't believe time travel's possible because otherwise we would have been invaded by tourists from the future." So the understanding of the physics is that if you look at how the numbers pan out, you could potentially travel in time if you could do various things. But as a mathematical theoretician said to me, you've got to be very cautious with theoretical maths because you can prove anything with maths, but it's the reality that really matters. And so at the moment, we are comfortable that the laws of physics forbid us to go backwards in time. But you know what they say never.
Bradley, good morning to you.
Good morning, Eusebius and Chris. I would like to find out, I have a toddler, was a baby obviously, and are they less susceptible to feeling or touch? I know if a fly lands on my face, I swish it away. If I've got some food stuck on my face, I remove it. But a baby doesn't have that, and they can't. Do they not feel these things like we can?
What a fascinating question. The answer is that they absolutely have very good senses of sensation, and this doesn't just start when they're born, it starts in utero. And researchers have studied the ability of babies in the womb to feel pain, and babies certainly can experience pain. Their nervous system is susceptible to sensations that we would describe as painful. Whether or not, though, at that early stage of development, their brain is wired up to interpret the sensation as painful, we don't know. What we do know is that by the time they're born, though, most babies do respond as you and I would if you subject them to, say, a painful stimulus. So if you pinch a baby, or it has to have a needle for a medical procedure or something like that, they will certainly flinch and they show signs of discomfort. So that suggests that they are interpreting and responding to those sorts of sensations. And painful sensations are, by and large, decoded and transmitted around the nervous system in the same way as other sorts of sensations like stroke and light touch. Now, the difference here, though, might be that when you feel a fly crawling on your face, your nervous system has all the right connections and the right wiring so that A, you know when you feel that sensation where the fly is, and B, you have that reflex wired up so you know to bring the right hand to the right place on your body to swat it away. The very underdeveloped nervous system of a very young baby is that it may well be feeling those sensations, but for it, the fly is not on a defined part of its body. It just knows that something's irritating it. It doesn't also have necessarily the coordination to bring a hand to the right part of the body surface to swat that fly away. So it may not be able to respond appropriately, but it's likely that the baby will be able to feel all those sensations. That's how we think it works at the moment.
It's 25 minutes after 10. We have time for one or two more questions. Kanya, welcome to the show. What is your question?
Thanks, Yuri. Dr. Chris, we are living in a country where there is a very high probability that in the next few years we will be struggling to have water in parts of it. And there is a theory that suggests that water can be produced from the atmosphere or from the air. Now, if that were to be done, what would that have in the long run as an impact on the environment?
Yes, indeed. I mean, we've seen in the last year, haven't we, the acute water situation in Cape Town. There are many other places around the planet that suffer similar water shortages. And with rising human population and rising urbanisation, we're likely to see more of this in the future. So people are very worried about this. The strategy that is being outlined is one, obviously, better distribution, because if we've got parts of the world with lots of water and we've got places where there are lots of thirsty people, then we have to get better at moving the water from where there's lots of it to where there are the people who want it. So that's one solution, is to develop better infrastructure. There's other solutions which include, as you've said, one idea is to use devices which effectively catch water from clouds, because there's water in the air and you can condense that water out. And there's a range of strategies for doing that, and there's a range of quite environmentally friendly ways of doing that. You're not going to dramatically reduce the amount of water in the atmosphere by a sufficient amount to cause environmental damage unless you were removing enormous amounts of water in this way. So I think probably the likely impact is going to be quite minimal of doing that, but at the same time it's probably not going to be the only solution, and it certainly won't work in all geographies and all locales around the world. So we have to have a range of solutions to this problem, including, as I say, better distribution, other strategies including things like desalination, as long as they are not environmentally very unfriendly, and also always have in the back of our mind that the chief drivers of many of these problems are how many people there are. And we need to keep an eye on human population because it's rising inexorably, and a lot of the problems that face the planet are because of the numbers of people. So therefore, population control and responsible population of the Earth is, at the end of the day, going to be a lifeline for the human race, because otherwise our quality of life will suffer just because of growing population.
Armando, good morning to you. What is your question?
Good morning. First of all, what an incredible show. I always look forward to The Naked Scientist, the absolute amazing. But my question, many years ago, about 18 years ago, I was fast asleep, I was in bed, and I was snoring. My wife leans over after she got sick and tired of not being able to sleep herself, and she grabs my nose and she blocks my nose until I wake up and I gasp for air. Ever since then, every time I'm in a very, very tired state, if I've had a very long day, maybe a night out, and the next day when I go to bed, the same thing happens. Without it blocking my nose, I stop breathing. So I think, wait, I've got sleep apnea. And I go and have the sleep therapy where they put all those thingies on your head and they check to see. And they say, no, but you don't have sleep apnea. Then I had some surgery done years later, and coming out of the anesthetic, that sort of phase where you're coming out and you're back in sleep and you're coming out. And again, this thing happens where I stop breathing. And I say to the nurse, and I said, did you see that I just stopped breathing? Because I didn't believe the doctor that did the sleep apnea test. She goes, you didn't stop breathing. Look, everything is normal. You were breathing normally. So what happens now is, as I say, when I go into deep sleep, this happens when I'm very, very tired. Is it possible that it is re-stimulation from what happened to me 18 years ago when I was in a deep sleep based on a subconscious mind or something weird like that, that now I stop breathing every time I go into a similar type of deep sleep? Yes,
Okay.
it's not apnea.
Okay, interesting question, Chris. And his relationship with his wife is at stake.
I was wondering if he was going to say, and my wife's lawyer would very much like to know. No. I don't think probably this is related to that one-off event. It doesn't sound likely that a one-off event where someone holds your nose when you're snoring at night is the cause of this. When a person snores, what has happened is, or what is happening, is that the soft tissues at the back of the throat, where when you go to sleep, the muscle tone around your neck relaxes because all your muscles relax during sleep. And those muscles also have a role in keeping your airway patent. And when the muscles relax, especially if there's a bit of extra weight around the neck area, so people, when we get a bit bigger and we get bigger around the middle, we tend to find that we are more likely to snore because the muscle relaxation and the extra weight around our airway makes the soft tissues flop back and block the airway partially, so that as you breathe in, you have to use the air coming in to push the soft tissues out of the way, and as you do so, they vibrate in the airstream, and that causes the snoring noise. So that's not going to change structurally because of someone just pinching a nose. So I think it's unlikely, but what it might have done is to highlight the problem to you, and so you notice that was happening. It does sound like perhaps you are having sort of airway obstruction if you're snoring a lot, and that certainly can be investigated. It sounds like you have investigated it, but I don't think that probably having your nose pinched once would cause a lifelong consequence. So I think your lawyer can be reassured that there's not a case to answer there. But your wife should certainly not pinch your nose at night. She did you do something? Did you forget Valentine's Day or an anniversary or something?
No,
Thanks, Armando. Thanks, Chris. Lovely first show. We'll do it again next week.
Thanks, Eusebius. Next time it'll be a pillow. If she comes back and if she says it's a pillow.
You won't be around to ask
No,
the question.
no, you won't.